Okay guys, today the topic of our discussion is two theorems. First is remainder theorem, and second will be factor theorem. First we will make discussion about remainder theorem. What is remainder theorem? As you know, when you divide 14 by 3, what will you get? This is long division method, and we have done this a lot of time in our previous classes. So this is the process. Okay, this is called remainder, and this is called quotient, right? And this can be written as this 14 when divided by 3, you will get quotient as 4 and remainder as 2. We have done a lot of time this point, right? This is the number system in which we apply this process or this pattern. Now we will apply this pattern on the algebraic expressions, means on the polynomials. So as you know, this is the number and it can easily be divided. But if we have two polynomials and we divide them, then it would take a lot of time and a long process, right? So is there any shortcut way to find remainder, or any way by which we can find remainder when we divide two polynomials? Okay, so I think it is a limited sense in this way, and the remainder theorem is generated for this. It is applicable in a very limited sense. I say it in a limited sense because when we use this theorem, or when we will see the applications of this remainder theorem, you will also learn this point, and I will clearly tell you why I say it a limited sense. Okay, you give the name here as dividend, right? This is called dividend, this is called divisor, and this is called remainder. For your sake, I will write here as this is dividend and this is divisor and this is quotient, okay, and this is remainder. Now if I take here a polynomial at the place of this 14, this number, so this polynomial will be dividend, right? And here I can say this is gx and this is qx and this is rx, right? This rx, r mean remainder, okay, this qx is quotient, right? This px, this is dividend, and this gx is called divisor. Means when we divide this polynomial with this polynomial by this polynomial, you will get this quotient and this remainder, right? In our first chapter, Euclid's lemma, we have used this process, right? And if you want to go in deep for this, but that was limited only to the numbers, and you want to go through from this topic on this topic, you have to see the videos of our first chapter. Right now I will make discussion on the remainder theorem. What is statement? I am writing here the statement of remainder theorem. Let px be any polynomial. Px be any polynomial. Right? This is px, this is polynomial of degree greater than or equal to 1. Means, what is the degree of this polynomial? That may be 1 or more than 1. What does it want to say? It want to say that this polynomial must not be constant. Means it does not have degree 0. Okay, this polynomial must not be constant, right? Let a, small a, be any real number. Be any real number if this px is divided by the linear polynomial x minus a. Try to understand this. How this polynomial exists. This is x minus a. As you know, a is any real number, and if I take it equal to variable, means at x is equal to a, you will get x minus a as 0. Try to understand what I am saying. If we write x is equal to a, then this a is called 0 of this polynomial, that is x minus a. Means a is 0 of this polynomial x minus a. So when the given polynomial px is divided by the linear polynomial x minus a, then the remainder is a PA. What is PA? PA is value of the polynomial px at x is equal to a. What remainder theorem says? Remainder theorem says that if you have a polynomial px, right, and you have a value, you have a 0 at x is equal to a, means variable value of a, and when you divide the polynomial px with the polynomial x minus a, you will get the remainder as value of that polynomial at a, that is PA, right? I think you have understood it clearly, the statement of this theorem. Now I will try to prove that. Okay, use this form, form with this statement. What you will get? Suppose suppose the given polynomial px is divided by the polynomial x minus a, we get qx as quotient and rx as remainder. So how can you write it? Px is equal to, when divided by x minus a, you will get quotient as qx and remainder as rx. Simple. Px polynomial, right? X minus a another polynomial, right? Px is divided by x minus a, then there exists qx quotient and rx as remainder, right? Now, as you know, this x minus a is linear polynomial because it has degree 1. So when you divide any polynomial with this polynomial, you will get this remainder. Then the degree of this remainder will always be less than or equal to the degree of the polynomial, that is quotient, right? As you can say, x minus a has degree 1, right? So degree of rx is less than the degree of x minus a, right? Now what will be the degree of rx? If you have a degree 1, then what is the next degree less than 1? That is 0. So degree of rx will be 0, right? So if a polynomial has degree 0, then it is constant polynomial. It is a constant polynomial. So this px can be written as x minus a qx plus r. Constant polynomial does not contain variable, right? Right? We have proved that rx, which is remainder, is a constant. Clear? Now at x is equal to a, you will get here pa, you will get here a minus a, that is qa plus r. This is 0 plus r, therefore that p is equal to r. Right? Very easy, no problem. The term which can be remembered here is that why the remainder is constant, right? Now the question arises, why we take x minus a linear polynomial? If there is quadratic polynomial, cubic polynomial, then what will you do? How you will find? So the word I used earlier in this video, the limited sense, this is the limited sense, because if here the divisor is not linear, then remainder need not be constant, and it becomes difficult to find the remainder with the help of remainder theorem directly. So the application of remainder theorem to find the remainder of a polynomial is in a limited sense, right? Now come to the exercise. We will see its applications and try to solve questions by using remainder theorem. The first question is, find the remainder when here px is given as x cube 3x square 3x plus 1 and the value of is divided by means you say the linear polynomial is x plus 1, right? Now I have to take 0 of this polynomial, so I will say take 0 of x plus 1. What is that? Which is minus 1. How? Put this equal to 0 and you will get the number, right? That is minus 1. So by remainder theorem, the remainder of given polynomial px will be p minus 1, right? What will be p minus 1? Put the value of minus 1 at the place of x. You will get your result. This is minus 1 plus 3 minus 3 plus 1 and this is 0. So remainder is a 0. Very easy. Understand? Right. Now I am taking fourth part of this. Here the linear polynomial is x plus pi, right? And 0 of this x plus pi is minus pi. So by remainder theorem, remainder of this polynomial is p minus pi. Put this minus pi at the place of x. You will get the required result. Okay, this is plus minus 3 pi plus 1. Okay, this is the answer. Now question number 2, find the remainder when here px is equal to x cube minus ax square plus 6x minus a. Linear polynomial is x minus a and taking 0 of x minus a is a. So by remainder theorem, the remainder of this polynomial is pa and you will find the value of pa, right? Very easy one. Don't get confused. Okay, so if you think I am doing a good work or a good job, then please subscribe our channel and also click on bell icon to get latest video of our channel, so that we get inspiration from your side and put more and more videos to clear your doubts on mathematics. Okay, and I request you, if you have any doubt or query, you can share with us in comment box. So the third question of this exercise 2.3, in which we have to check whether the given polynomial is factor of that or not. I will try to give answer of this factor or this question in the next exercise. So the next topic of our discussion is factor theorem. What is factor? Can you tell me about something factors? What are factors? As in our first chapter, we have discussed a lot of points on the word factor, but that was applicable on the number only. Number, yes, we find prime factors, and in our previous classes also we have find many prime factors. So if I say you have a number 20, you will find the factors with this process. I think very old process, and you write this as right. Now come to the discussion. This 2 is factor of this number, right? How can you say this is the factor? If I write here 3, would that be also a factor? If not, why? Very easy one. This 2 is factor of 20 because this 2 divide it completely. What does complete division mean? Complete division mean remainder 0. If you divide 20 by 3, you will not get remainder 0. So 3 is not factor of 20. Very easy. This point you have done a lot of times. This is 5. 5 divides 20. What does it mean? It means 5 is factor of 20. It means when we divide 20 by 5, we will get remainder 0. So if a number divide another number and you will get remainder 0, then the divisor will be factor of that dividend. This result can be applied on the algebraic expression. Okay, how? Here I have taken number, and in algebraic expression we have not numbers, we have polynomials, linear, quadratic, cubic, and so on. You can take any polynomial. So what would you apply? How you will apply? How you say? I will say if a polynomial is divided by another polynomial, right? I use the word polynomial on the place of the word number. Nothing different. Same process, same thing, right? If I divide a polynomial with another polynomial and I get remainder 0, if I get remainder 0, then the divisor polynomial will be factor of dividend polynomials. Okay, I write it as, if you have px as dividend, right? Gx as divisor, Qx as quotient, Rx as remainder. This expression, okay, algebraic expression. If Rx is 0, Rx mean remainder. If remainder is 0, then this Gx, right, which is divisor, this Gx is called factor of polynomial px. Very easy, right? I will take example to prove my point. If you have a polynomial px which is equal to x square minus 3x minus 4, right? And x plus 1 is another polynomial, right? So 0 of x plus 1 is minus 1, right? I am finding remainder. I am trying to find remainder at this. Put x is equal to minus 1. This method has been done in the upper part of this video. This is 1, this is 3, this is 4. 0 means remainder 0. What does remainder 0 mean? X plus 1, this is divisor polynomial, is factor of x square minus 3x minus 4. So to check a polynomial is whether factor of another polynomial, we have to find remainder. If remainder is 0, then it is factor. If not 0, not factor. So very easy. I think you have clearly understand this. Now come to the theorem statement of factor theorem. If px be any polynomial of degree greater than or equal to 1, okay, means constant polynomial does not matter here, means constant polynomial cannot be applicable here, right? Let a be any number, then first point, x minus a is factor of px if pa is equal to 0. In remainder theorem, I clearly told you that this is the process of finding remainder of the polynomial, right? So here pa is remainder, right? And remainder is 0. If remainder is 0, then this linear polynomial, this divisor polynomial will be factor of the dividend. Second, if remainder is 0, this remainder is 0, then you can say x minus a is factor. Is there difference in this point? Means if you have given remainder 0 at this point, then when will it be 0? If this is factor of the polynomial, right? I can write it as x minus a is factor of px. prima facie you see that these 2 points are same, but in explanation in deep you will see some difference. Here there are 2 points. First, x minus a is factor. Second, remainder is 0. So combine these 2 points in a single statement. How will you do that? If x minus a is factor, remainder is 0, then remainder is 0. If remainder is 0, then x minus a is factor. These are 2 points, right? First, if x minus a is factor, remainder is 0. Second, if remainder is 0, then x minus a is factor, right? These are 2 points. Now come to the proof. First you can take remainder is 0. Taking PA is 0, right? If PA is 0 means it is given. If remainder is 0, then we have to prove that it is factor, right? So use the format that we have right on the above this page, as we have px is equal to x minus a into qx plus rx, right? What is given here? So here remainder is 0, that is PA, which is equal to 0. So px is equal to, this is remainder, right? And x minus a into qx plus 0. So x minus a and qx, right? This px is completely divisible by qx, so x minus a is factor, right? This is first point. And second point, let x minus a is factor of px, means this is given, right? This is given, p minus x is factor and this is given, right? If this is factor, then by remainder theorem, what would be remainder? Then by remainder theorem, PA is remainder, okay? And PA is remainder, PA is remainder, right? What would be remainder? Right here as px is equal to x minus a into qx and rx, right? Now to find PA, we have to put x is equal to a. You will get here PA, a minus a, QA, RA, right? This is PA and this is 0, O. As x minus a is factor, so remainder is 0. and to write here Rx, you must write here 0. Okay, be careful about this. Write here 0. So PA is 0. What we have proved? We proved that if x minus a is factor, then remainder is 0. And in first part, if remainder is 0, then x minus a is factor. So this is the factor theorem. So if we have to prove that one polynomial is factor of the another polynomial, we have to find just the remainder of the polynomial at the 0 of divisor polynomial, right? If we get remainder 0, then that would be factor. If not, then not factor, right? So I think you have clearly understand. And now let us take some example or come to the exercise 2.4. Question first. What it said, determine which of the polynomial is factor. Here the given polynomial is x cube plus x square plus x plus 1, right? Now we have to check whether x plus 1 is factor or not. So take 0 of polynomial x plus 1, that is minus 1. How you did this? Put this equal to 0, you will get the value, right? Now we have to check whether we check p minus 1, right, is 0 or not 0. What is p minus 1? This is remainder, right? P minus 1 equal to minus 1 cube minus 1 square minus 1 plus 1. This is minus 1 plus 1 minus 1 plus 1, and this is equal to 0. So p minus 1 is 0. Remainder is 0. By factor theorem, we say that this polynomial is factor of this polynomial one, right? Very easy. I think points are clear. Okay, I am taking fourth part of this also, as px is equal to x cube x square 2 plus root 2x root 2 and minus 1. If I put here minus 1, find the value of this one. This is minus 1, this is minus 1 plus 2, root 2 into minus 1 plus root 2 minus 2 minus 2 minus root 2 plus root 2, and we have take here negative sign. This is negative 1 and this is negative 1, this is positive, this is positive, and you will get this is negative, this is positive, right? And you will get this value. So here you see remainder is not 0. So x plus 1 is not factor of given polynomial px, right? Now second question, use factor theorem whether gx is factor of px in each of the following. Means we have to verify whether gx is factor of px or not. The first one is that px is equal to 2x cube plus x square minus 2x plus 1. Okay, and this gx is equal to x plus 1, right? Means we have to check whether gx is factor of px or not. So gx is linear polynomial and you can easily find 0 of gx, right? So as 0 of polynomial gx is minus 1. Now find the remainder at x minus 1 and check whether it is 0 or not. If it is 0, then by factor theorem you can say, as you see here, it is 2, right? Let us check whether it is. There is no calculation point or calculated point. Here we see this is 2, this is minus 1, minus 1 square, this is minus 2 and minus 1 and plus 1, and this is minus 2, this is plus 1, this is plus 2, 1, and you see here is 2, and therefore we see remainder is not equal to 0. So by factor theorem gx is not factor of polynomial px, right? So this is not a very big one, big problem, big point. We have just to check whether 0 of a polynomial is 0 of another or not, right? Very easy one. Now come to the question number 3, and I will choose a point here, part 2 question, and this is also here given that x minus 1 is factor of px. X minus 1 is factor of px. So by factor theorem p1 must be equal to 0, right? What is 1 here? 1 is 0 of this, right? 1 is 0 of x minus 1. Okay, so p1 must be equal to 0. Here what is px? That is 2x square plus kx plus root 2. As x is equal to 1, this is root 2, given it is 0, this is 2, this is k, this is root 2, and you see that k is equal to minus 2 plus root 2. We have to find the value of k if x minus 1 is factor of the polynomial. So easy. Now come to the question number 4. Very easy one. We have to find factor. What is factorization? Process of factorization. How to find factor? First, here there are a lot of methods to find factorization or to find factor of a polynomial. One is factorization how factorization can be done? First, by factor theorem. Second, splitting middle term. We'll discuss these two processes. Okay. First is applying factor theorem to find the factors of a polynomial, right? What factor theorem says? Factor theorem says that if, let us take example. First, this is 12x square minus 7x plus 1. This is our polynomial, right? Okay, we will use factor theorem. We will use factor theorem. You can say that if this polynomial values 0 at a point, then that point must be 0 of a linear polynomial, and that linear polynomial will be factor. I will use this process. Okay, so first take 12 common and let a and b are factors. Okay, if they are factors, then x minus a, x minus b must be equal to x square minus 7 by 12x plus 1 by 12. If you write here 12, here also you have to write 12, right? Easy. Now multiply these as 12 x square a plus b into x ab, and this is equal to 12 x square minus 7 by 12 plus 1 by 12. Okay, compare coefficient of x here equal to coefficient of x square, right? This equal to this and this equal to this, means AB equal to here what is 1 by 12. AB equal to 1 by 12, right? This is 12 AB, this is 12 into this, and you will get this number. You can write it as 1 by 2, 2 and 3, right? So keep this in mind. You have to find possibilities. Matlab means possibilities of values of a and b. Here if you take a 1 by 2, then b 1 by 6, right? If you take a 1 by 4, then b 1 by 3, right? If you take a 1 by 6, b 1 by 2. If you take a 1 by 3, b 1 by 4, right? Again, if you take a 1 by 1, b 1 by 12, and a 1 by 12, b 1 by 1. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? Now check whether at these values this polynomial, the given polynomial, is 0 or not, right? So take first a 1 by 2, b 1 by 6, right? a 1 by 2, b 1 by 6. p of 1 by 2, 12 into 1 by 2 square, 7 into 1 by 2 plus 1. This is 12, 1 by 4, this is 7 by 2, this is 1, right? This is 3, this is 4, you see not equal to 0. So check whether p of 1 by 3 or p of 1 by 4 is 0 but at all non-zero. Except these two, p not equal to 0. So a 1 by 3, b 1 by 4, 3a minus 1 equal to 0, 3b minus 1 equal to 0, 4b minus 1 equal to 0, and you will get 3x minus 1 and 4x minus 1 are factors. Okay, very easy. This is application of factor theorem, right? So you can make factor. It is very long process. Also you have to take here, if you take here minus, then the possibilities are that if you take minus 1 by 2, then be also minus 1 by 6 and so on. So it is a long process, and in my next video I will discuss the method of splitting of middle term. So keep yourself in touch. I'll put the next video very soon, and that will be last video of this topic. Okay, thank you.